Well, good morning, everybody. I'm going to start off today first by covering this past weekend's wind event. We're going to move from that into the cloud cover for the eclipse later today. And then we've got quite a bit going on in the near and long-term forecast, including a multi-day severe weather risk event that's going to start in the south and possibly move into the Ohio Valley. We're then going to cover the temperature trends. We did see a little bit of interesting kind of signals toward late April that could bring another shot of some cool air in on a stacked low. Not liking that for much of the eastern part of the country. And then I'm going to dive right into the new long-range data. I've got new National Multi-Model Ensemble that's going to take us all the way out through summer into early fall, and also new ECMWF data in there as well. And we'll finish with South America. So grab that scroll bar at the bottom, go to the part you want, but we're going to start off with yesterday's kind of day 2 of the wind event that hit parts of the plains. So again, if you've been staring at the screen for a while, this is not the cloud cover right now. This is a cloud cover on Sunday. And as this low emerged out of parts of Colorado and Wyoming the day before, the winds that came down slope off the Rocky Mountains and into the plains were hitting speeds of over 80 miles an hour. And there was a large dust storm that resulted from this, which is common in spring, but we always just keep an eye on those this time of year. You can see as I kind of let this get out toward the very end of the kind of day as the sun was setting here, we did have some pretty nasty storms that kind of popped off right here through this part of Illinois and Indiana. But take a look at that dust right in through here, just sandblasting so much of this part of Kansas into Missouri. And again, remember the day before it was quite widespread farther to the south, extremely windy event, wind speeds 50 to 80 plus miles an hour, stronger coming off the mountains, and just has us questioning a lot of things. And I'll tell you the question that's on my mind. You know, last night I was talking with my wife. Again, we live right over here near Champaign, Illinois. And we were, of course, dealing with strong winds as well. Our winds were 45 miles an hour. That's still fast, but nothing like was experienced in the plains. And she says, is there some sort of trend to this? I mean, she just asked me. She's a nurse, but she's noticing like, hey, something going on. I just want to know. So I started a little project to try to figure this out. And it's going to take me a little bit. But using wind data and telling you about longer term trends is very tricky. And let me tell you why. If you have, let's say over the last decade, while you're looking at this map, the wind speeds increase 2 miles an hour. That seems insignificant of a number, right? But if you have a net increase in scalar wind speed of 2 miles an hour, that's like probably 3 standard deviations above the mean. And what I need to do is continue this work both using weather stations and also using some reanalysis data. Now, the map you've been looking at is just 30 foot or 10 meter zonal wind. That means I'm only looking at the west to east component. I just made this quickly this morning after her question kind of marinated in my head last night. And I do want to make a point here. These colors would represent where the westerly winds at the surface. Okay, we'd call these surface winds, even though they're up 10 meters, 30 feet. But these are near surface winds. These colors represent where it's getting less windy from west to east, like here through here. Now, and this would represent where it's getting more windy. Now, what are the time periods over which I'm comparing? I tried to go back just a decade. So I looked at the entire year from 2014 to 2023. So each of the years, I should say, but January to December from 14 to 23. Then I compared it to the climatology, the average. And take note that across most of the United States, we didn't see an increase, but there is. Just take a look at what's coming out of this part of the Canadian prairie into the plains. What I need to do next is just get the V wind component or the north-south wind component and do the meridional versus zonal and come up with a total wind. And that'll begin to answer this question. We'll look at individual stations too. But there's a lot of people that are in the midsection of the country that have talked extensively about recent wind events. And I'm just going to make one simple point about wind, especially in spring. If you get a lot of cold air north and a lot of warm air south, it's going to be very windy in the middle. That's just how it works. That is how wind is created. Wind is a result of a pressure gradient. Pressure gradients in this particular situation aren't coming from elevation. They're coming from the differences in temperature. And ultimately, that's what drive winds, differential heating. Okay, that was a lot about wind, but I just want to let you know what I'm thinking about here. Now, yesterday, just take a look at this kind of zoomed in here. Look at the widespread dust that was coming off of this. And there were a couple of fires in here as well, as you can see some of the smoke. But at the end of the day, there is an elevation-induced wind event, and you can actually see it in the wave clouds that are coming off the Rocky Mountains here. These wave clouds, as you can see, kind of line up right through here and here, and they're going to basically outline the shape of the downslope coming off of the Rockies. And sometimes these take on the form of what's called a hydraulic jump, where the winds come down and then they just bounce back up and create this cloud. And it kind of has a standing wave that's related to the speed of those winds. So just, again, for many in the middle part of the country, it was an incredibly, incredibly windy go of it. All right, how about these clouds? Now, I record this before the sun rises, so the issue here is I'm going to have to use infrared satellite data. And remember, the infrared is really going to show you the high-level cloud, and that may be one of our greatest kind of impediments to seeing the solar eclipse today, is high cloud throughout this part of the track later on this afternoon. Now, early this morning, if you went down here and you're in southern Illinois or southern Indiana, there is incredibly dense fog down here this morning. That will fade before the eclipse gets here. But as it stands this morning, this is what the cloud cover looks like early. Now, I will confess, I don't spend a lot of time researching and studying cloud forecasting. That's just not something I've put a lot of effort into. Maybe I should have. But I will show you what the models are putting out for later today. And I also want to point out this. Looks like they were pretty well initialized. So we're looking at cloud cover in these shades, okay? This is now, and this is how the model was initialized. So as we see it doing a pretty good job with that initialization, I'm going to take you right up to about when the eclipse starts at 1 o'clock this afternoon Central Time. And remember, the track of that eclipse is somewhere, in through here. And as you have a close look, it does appear that we're going to get some open viewing, although there might be some high cloud in here obscuring some of this. It may be a bit more of a patchwork of clouds that cause some of the trouble viewing it from Ohio all the way to New York and Vermont. And as you come out of Texas, our biggest concern is that later today there's going to be the risk of strong to severe storms. Maybe it's post eclipse viewing, but watching the atmosphere build into that is going to be tricky. So is it ideal? No. I mean, if it was up to me, I would just plant a massive area of high pressure over this and give everybody a good view of it. But that's not how things work. So if I had to pick a guarantee, I'd say go to Maine, but I wouldn't go to Maine. And early this morning as the sun was rising in Maine, you can actually still see there is snow on the ground in parts of Maine. And they had a big snow event, of course, last week. And so to travel here to see this would be it'd be quite cold. But people do that. It's whatever, just is what it is. But by the way, since it's just a hair after 6 a.m. Central Time, I would like to show you what sunrise looks like so far. And so this will be a shield of cloud that we're going to watch move all day today. That I think is going to be problematic for the viewing in this area. And then we've got what's coming out down here to the south. Could there be a better viewing point right in the middle? I think possibly. And then, of course, in the northeast. So that's just kind of a quick rundown of what I think might happen later on this afternoon. From here, since I mentioned snow, I do want to show you that over the last 72 hours, we had a really good late season snow event that hit parts of Montana and came down into this part of Nebraska. And this morning it was snowing here in this region as well. But just to think about snow, this is where we currently stand on our snow water equivalent. So remember last week's major event that hit this area with some places over a foot, and then the heavy snows here, just to show you where that snow is right now, okay? But I wanted to put this back into contrast of a year ago. So this is where we were a year ago. Look at the northern plains and upper Midwest. We had in some places here 2 to 6+ inches of liquid still sitting in the snow. And while the west from the Colorado Basin, let's go back to the previous map, from the Colorado Basin to the Sierra Nevada is doing very well this year on its snow water equivalent. This recent snow to the north was an outstanding additional kind of push toward finishing off the season well with just thinking about the water resources through the remainder of the season. But notice there's not a whole lot still left to melt here to come down the Mississippi River. And the Mississippi River did make a bit of a spike up lately. So it's now about 13 and a half feet above low stage at Memphis. But a lot of that was due to the rainfall that hit the Ohio Valley getting into the Ohio River a week ago. All right, speaking of recent rains, let's just take a look at the last 2 weeks. Because as I look at this, I see some holes, of course, larger ones down here, Kansas to Colorado, Oklahoma, Texas. Ones that will be getting filled in a major way are going to be here in the Mid-South. This large swath right in through here in Texas, and this pretty significantly large area in the Red River Valley of the North, extending into North Dakota and also into Manitoba and Saskatchewan. This is going to be another area that I think is going to see a spring storm system come through and fill this in. And I actually don't think we're done with snow in through this area based on some of the new forecasts. So we're going to have to get in there and have a close look at that in a few minutes. So last couple of weeks of precipitation, big question is who's going to get the beneficial rains coming forward as we work our way into this spring? Because as we look down there, again, we did this Friday, but let's look again. At 100 centimeters or 40 inches, there are areas that still need to have a solid push of moisture. Much of Missouri and Iowa, Kansas, Oklahoma, Arkansas, the Mid-South, this whole region, getting into southern Michigan. These are spots that just need a big push of moisture. And like I said, some of those areas are going to get it. This past weekend, that storm system that came out produced 2 rounds of severe weather, one here and then a second one here on Sunday. And we can just take a look at those storm reports. 46 high wind reports from thunderstorm events on Sunday. And there we go. As we get to, that was Saturday. Let's go back to that. Sorry about that. This is Saturday's data. And as we then go to Sunday, there you go. So we had, let's see here, 16 total reports, 1 tornado, and some of this putting down some decently sized hail. All right. Right now this morning, 6:05, we've got flood watches out here, and there's the fog. On the back side of this current storm system, we do have the winter storm warnings and winter weather advisories. Thankfully, we do not see widespread wind event happening today. But the winds are going to be critical in understanding the severe weather threat that's going to be setting up across the south. So have a look. Let's go to the upper levels. This is kind of a very, very important view of what this particular system is capable of doing. As we just kind of zoom out here, let's get you a better look on this. I want you to see what the jet stream's up to. There's the broad trough coming out of the polar jet. There's actually a secondary wave sitting right here, but the broader trough has got a tilt on it like this. Okay, so that would be a positive tilt, which means it is going to dig. It's going to move in this direction. Digging troughs that come off the Rocky Mountains, which have a subtropical component to their south that adds into them, give us an ideal setup for severe weather in this part of the country. And the reason for that is the upper level wind speed is fast and it's coming from this direction. The near surface wind speed, take a look at this. It's coming up out of the south and could be at speeds, 30, 40, 50 miles an hour. The surface winds are getting pumped around this high pressure cell, and they've even got a component that's even from the south and east. And there will be a frontal boundary, 2 frontal boundaries that come through here that are going to help initiate these larger storms. So the wind shear profile is there. The moisture will be there because it's coming off of the Gulf. And we expect today to have a severe weather event that's going to happen down here in parts of Texas. So looks like the largest area for the risk of severe storms, including hail, straight line wind, and also tornadoes, is going to be here south of the Red River, getting to this part of central Texas. This storm system is not moving fast. By the time we get into tomorrow, the 9th, it's moved into eastern Texas and Louisiana. And then as we get beyond that, here it is on the 10th. 3 days, enhanced risk. So if you take a look at where you are on their risk scale, we're here all 3 days. And then as we get into the day here on day 4, which gets us out there to Thursday, the Ohio River Valley, parts of it, and the southeast has that risk. Now, as we watch these storms evolve and move, just have multiple sources by which you can keep track of severe weather. We're no stranger to it down here, and it's spring. We expect this, but we just need to be aware of what's going on today through Thursday. Now with this, we're going to be bringing a lot of rain, and I want to show you something first. This is since the beginning of the year, we're looking at precipitation ranks. And again, you can very clearly see the wet areas, but this is one area that out of the next few systems, I'm not necessarily seeing picking up a lot of rain. But this region in through here and this region in through here are going to get soaked. And then there's a system following it that we're going to watch for the Red River Valley of the North. So given that, let's kind of walk through and try to find how and when these systems are going to come through. We're going to start up with the high-res models. This is the high-res NAM. Okay, I've got this queued up for about 8 o'clock this morning. So this is, again, is where the snow is this morning. And the low is spinning its way through parts of Minnesota straight into southern Manitoba. This afternoon and this evening, we're going to keep a close eye, watch this, on these storms right here. So this gets us into tonight. And that's where the risk of these larger storms are going to be. Some snow in the Rockies. There's some snow up here in the Cascades. The upper level low that's dying here over Minnesota, Manitoba, Lake Superior. And the next one that's coming out down here to the south is what we're going to watch. So late this afternoon and this evening, okay, getting into the overnight hours, broad shield of heavy rainfall coming into this area with embedded severe storms. As we work our way into the overnight hours into early Tuesday morning, that low has not really progressed very far. So by midday Tuesday, getting into Tuesday afternoon and evening, the backside of this low is sitting and spinning, delivering a lot of precipitation here. Now, it is very possible that around Lubbock, we end up having a tremendous amount of rain, and Amarillo could miss it. I mean, that's how that's how small this system is and how hyper-local the rainfall totals could be. But this is getting into Tuesday night, playing through the rest of the day on Tuesday, getting into early Wednesday morning. That heavy shield, or that shield of heavy rainfall, moves toward the Delta, moves here toward the mid or lower Mississippi River Valley, and possibly delivers quite a bit of precipitation. That's just the beginning. This low is still sitting here. All right. So what we're going to do next is we're going to kind of take a look at a multi-model analysis of not just the next 3 days, which is what you saw, but the next 10. And the artificial intelligence version of the ECMWF has been very keen on the heavy rainfall expected here. And you can now also see what it's doing in terms of delivering that moisture back into this part of Texas while leaving a stripe kind of right in through here. But it's honestly a bit larger than that we don't expect a lot of precipitation over the next 10 days. Now, there are places in here, of course, that need this moisture, but we're also going to be getting into that time frame where we're able to plant a crop. So to not have it during planting could be key. But the models did trend much wetter here north, up in the Red River Valley of the North. And I want to show you how and when that's going to get there. Now, we still have heavy rain moving toward the northeast. We have another system that's coming into the west. There's more than just what I was talking about in the central United States, but as you look at precipitation compared to average, I just wanted to show you the split. This is the European ensemble this is the operational European model 10-day forecast compared to normal. So very wet down here. Some places picking up an extra 3 to 4 inches compared to average. Then you have this spot right in the middle where we're looking very, very dry. And then there's a system I'll show you in just a few moments that could be coming in, hitting the Dakotas into Saskatchewan and Manitoba. Now, outside of that, we'll watch another system slide like we've been seeing them north-south into California, but much of the Northwest is going to be on the drier side of average, especially the coastal regions. So how about another way of looking at it? Probability maps. This is the 10-day probability of getting at least an inch. And you can start to see this little drier area, but watch this. There's the chance at 2 inches. Right now, the model has a 90 to 100% chance of 2 inches in this area. And 4 inches, we've got a 50 to 80% chance of 4 inches in the next 10 days. And on the drier side of this, if we just look at who's got this potential for staying under, it's this area extending from, just north of that heavy rain in Texas, all the way up to this part of Nebraska, straight through. In fact, let's go look at the half inch. This is who's getting less than half of an inch. So tucked away in the middle is this drier area. All right. Now, what it looks like in the upper levels of the atmosphere is shown to you here. And I'm going to show you the artificial intelligence forecasting system's forecast of upper level heights because of one reason. And that reason is going to show up right here in the northern plains at the end of this animation. Ready? So this is through Tuesday into Wednesday. So what are we watching? That guy. That's the slow mover that gives us severe weather threat 4 days in a row across the south. So that low sneaks through. We then watch this weekend. Here's our next low that moves straight from the north to the south. That's the one that produces the precip next weekend into California. Now, as we watch that low, this would be next Monday. It sneaks over the Four Corner states by next Monday night, meaning next Monday night, should this be in the right place, okay, we will be talking about the risk of more severe weather here. This is the typical spring ejection of troughs out of the lower Rocky Mountains, or the southern Rocky Mountains. Okay, now, as that system takes form, what is interesting about it is this. Remember what the previous one did? The low that's here today? It goes like this, doesn't it? This low will do this. And what's important about that is as it traverses its way toward Iowa and Minnesota, it kind of links up with a bit more colder air here around the 17th. And what I don't like about this is that, one, this could produce some very, very heavy rain and big snows on the backside right in through this area. But two, this low could end up developing, stacking itself up in what looks like an omega pattern to the east. Now remember, anytime I say omega, you just think slowing down. All right, just slowing down. It's going to slow the pattern down as it's trying to move to the east. And what we don't like about that is that gives the chance for the system to stack itself up with the upper level low sitting on the surface low. And what this is this is Friday the 19th. Should that be there, this is going to be a late frost event that I did not see on Friday. The models weren't picking it up on Friday. Okay? That's what we're going to watch out for. Now, is it in any other forecasting system? Let's go to the European ensemble. No, it's not there. Okay? It's just not there. What about the GFS ensemble? Not really. So this is sorry. That's still good. Let's go back to the artificial intelligence. It's there. Now, we have yet to get really burned by the artificial intelligence forecast model, right? I mean, we've been using it to kind of look for these things, and I've got it on full test mode. I want to know how well it's going to do. So let's stuff away this time, 18th and 19th, well, let's call it 17th to the 19th, as the risk of Great Lakes cold right there. Does it move east after that? Boy, the model wants to do that. So I don't know. We're going to watch it carefully. If you get, I'm just going to say it one more time. If you get this, that ridge in between, yes. But again, it's only showing up in the artificial intelligence. It's not in the ensembles. So let's do a comparison. We got something to study together, okay? Okay, just so you know, if you compare the European operational to the GFS operational to the new ensemble, not the new ensemble, the new artificial intelligence, it's been doing a better job. And I'm only showing you that because I want you to know that part of my test is to see if it continues to outperform. Now, this is not the European ensemble or the GFS ensemble. This is just the operational, and it's been the better model. Okay, so what do we do with it? Let's start comparing. Now, this won't take you out that far. This will only go out 10 days. That cold air is out there 11 days out, okay? So what we'll watch is through Monday into Tuesday, there's the heavy rain event, the severe weather event to the south. This is still here Thursday morning. It moves up to the Ohio River Valley. There is at some point going to be a very sharp divide right here. That's where it is in the GFS. Here it is in the European, where we're going to have a very heavy rain east of that line and almost none west. What will be west is, take a look at the isobars. See how tightly packed they are? It's going to be very windy in the west. This is Thursday morning into Thursday afternoon. That system rolls up, moves into the east, very heavy rains, persistent rains through Thursday night into Friday. And then as we watch this system leave on Saturday, the country gets a little bit of a break. The next low slides down here, and this is the one we're going to watch do this. Okay, so here it is Saturday evening, sliding into California, gets over into Arizona by Monday. Now watch where it comes out. See where it does this in both models. Comes out somewhere like the previous one just did. I mean, this is almost a copy of what happened on Saturday. I mean, almost the same thing. Strong winds, very deep low, slides right here. And if you notice on the northern side of it, it's potentially putting down some very heavy snow here. Now, this again is before we see the deep stacked low possibly form in this area, but this could be a part of it. So I want to be watching that 17th through the 19th, the risk of some colder air coming back into this area. Okay, what about week 2? Now that you saw that, I just want to show you the new, my new maps here from the European ensemble match the GFS halfway well. I mean, pretty good. I like this. They kind of have a similar setup here, suggesting that the midsection of the country sees some wetter conditions in through here. I think in between, there's going to be open planting windows for much of the Corn Belt. They might get in there and get that done. But all three forecasting centers do say the West Coast is drier into week 2, which for many in the West Coast is not a bad thing. So let's take this back and look at the temperatures once again. Frost potential for the next 7 days. Today's highs. Take a look at that. Major warm-up happening here in this part of the country. As we then go from Monday into Tuesday, this is where that low sits and spins on Tuesday into Wednesday. All cloud cover driven here by Wednesday. Thursday, the system's trying to move itself up the east. Larger ridge builds into the west ahead of the weekend low that slides north to south. So that's Thursday, getting into Friday. Why does it cool off in the west Friday, Saturday? That's when the low is here. And this is the low that's going to be sitting here on Saturday. That's going to be moving through California and end up somewhere here early next week. And that's when we're going to watch replace a lot of this warmer air with the potential for a cool down again. But rapidly fluctuating temperatures, all along I've said tax day. Well, I'll make an amendment to that, just a brief one here. If that low that's coming out here on the 14th and 15th, 16th really, the 15th, 16th, right in this area, if it does link up with an omega pattern to the north and east, it'll drop cold air into this area and produce another frost event somewhere around the 17th through the 20th. Now, as I told you, the ensembles aren't picking it up. This is the GFS ensemble out day 5 through 10. Here it is day 10 through 15. You don't see it, right? We just don't see that colder risk. The European model's kind of going, all right, that's day 5 through 10, mostly driven by that colder event from the low that's sneaking down here this weekend. But then day 10 through 15, it's trying something, but it's not linking up the really cold air in this area that could potentially be there. So we've got something to watch together. We'll keep analyzing that as we go throughout this week and next. Okay, I want to also point out that the longer range models, which we know, and I've said this many times, they are very much biased toward persistence, which means whatever they're started with, they tend to keep. But here toward the end of April, getting out there to the beginning of May, the model keeps the central United States much above average in terms of temperatures, still cooler along the spine of the Rockies and the western mountains here, cooler along the Appalachian Mountains, into the mountains in the Northeast. But models aren't signaling anything crazy in terms of cold. In fact, if you use the GFS ensemble, it just wants to make everything really, really warm through the end of April, all the way into, let's go back to the previous run and do the extended. There we go, sorry. This wants to keep everything warm for a while. Really quite warm for the country. Could that be because the MJO failed to get over here, that we have these risks of colder air? Possibly, but the linkage between the MJO right now and anything else is pretty weak. So CPC released this. They're April 20th to May 3rd. So in other words, just following that cold event here, they've got the end of April through beginning of May very, very mild. So maybe I would just make this suggestion and you don't have to take it. But because I think there's a risk in this area around the 17th through the 19th of going cold, we may just need to be patient to the end of the month before we make a breakaway toward warm conditions. Maybe that's what it is. Do I think there'll be open planting windows this spring? I do. I think especially into this area. This is the outlook from April 18th to May 18th from the European model. Sure, I would buy this. I also think there's going to be a lot of severe weather here moving through the southern part of the United States. West goes over a bit drier. Okay, deep breath, because I now got to get to the longer range stuff, which is going to start off with a discussion about El Nino. As we talked about, the cooler water is going to be surfacing in this area, and it is. We made a big deal on Friday about this cooler water that we're going to continue to watch. But right now, the new European model, which was released midday Friday, is gone with a less of a progressive pattern toward La Nina than it had. Previous runs were expecting ocean temperatures to be somewhere down here by August, September, approaching, weak La Nina. The new ensemble average is somewhere in here, which would be still in neutral conditions. This is a far cry. Look at that. That's not calling for a major La Nina. This is a far cry from what the CFSV2 is doing, which, again, that's -1 right there, right? So it's just crashing through that by summer, getting down to -2 by the time we get into midsummer. So much stronger progression toward it. So what does this mean? Well, all of the stuff I talked to you about on Friday about ocean temperatures, watch it with me, okay? Here's April into May, June, July, August. Now, can I go back? We analyzed June. And right now the model's putting warmer water here and a weak kind of beginning to a La Nina there. And then as we go forward into July and August and September, very warm water here, supportive of the hurricane season forecast we talked about. No major cooling off here. And our La Nina is significantly weaker, possibly even a negative IOD. All right, what does that mean? Well, if we come into the United States, that's not the United States. There we go. We look at precipitation. We get this. Let's come back here and watch this. April, May, June in the models. Green, wet, brown, dry. Let me rephrase that. Green, wetter, brown, drier. April, May, June. May, June, July. The model is still taking the drought out of Mexico, bringing it somewhere close to this part of Texas, and just opening it up throughout much of the Great Basin and the Great Plains, stretching it all the way into the Canadian Prairie. That's what it's got May, June, July. And then by June, July, August, still a lot of stormy activity here. It's trying to bring some drier conditions maybe into the Mid-South, but anchoring it back here in the Four Corner States out of Mexico. And then July, August, September. It's showing late season, late summer heat and drought. And that actually is what's funny to me, because that means the European model, even though it went with a less progressive movement toward La Nina, defaulted more to what the NMME said about late summer, which I'm going to show you next. So that's August, September, October. Active, very active hurricane season seems to still be there. What did the new NMME do? Well, this is its forecast for May, June, July. And as we go into June, July, August, see what it's doing here? Coming out of the Four Corner States into the plains, western Corn Belt to the western Great Lakes. Wet on either side. This is a very odd pattern to me. I actually don't get it. I'm going to have to spend a lot of time this week figuring this one out. Why? Anyway, July, August, September, still there. And then August, September, October, almost the exact same thing that the Europeans said. So what about one of those models in it called the CFSV2? It also trended drier here in April, May, June, July, and then bridges the gap with the dryness. This is June, July, August, September. And what I don't get is my analogs were this, remember? And I had convinced myself that this is the right call. But we do that sometimes, right? I mean, maybe I'm confirming my own biases, or maybe I'm a hammer looking for nails, right? And these are the nails I keep wanting to find and want to hit them. I hope I'm not conflating ideas here between what I expect this El Nino to do and what it's done in the past as it fades and goes away. But I've been telling you that I'm mostly worried about the Cotton Belt rather than the rest of the country. And the newest forecast just came out and said, well, through summer, maybe you shouldn't be worried about the Cotton Belt. Looks like it's going to be stormy and not a major risk of drought down here, or here. But you better be looking out for it west, moving into the Corn Belt. I have no idea. I've got to spend more time researching this because I felt as though this made the most sense to me. So now you know what I'm struggling with here as I start working on this longer term. Okay, one last thing to go over, and that's South America. It's raining everywhere except for like Minas Gerais, which is this place here. I'm probably saying that wrong, but this state. And heavy rains coming on some dry areas here in Mato Grosso do Sul to Paraná, and better rains coming back in Argentina. It's dry north of the Amazon, but safrinha crop getting a big drink. All right, I'm going to stop it there. Thank you for paying attention to me today. I'll give you a new update tomorrow. Get some more time this week to think through things, and we'll report it back to you. Thanks.